Today we will see about Van de Graaff generator. So first of all, what is this? It's a device which is used to produce electric potential of the order of millions volts. So this generator is a device. Van de Graaff generator is a device or is a machine. This is a machine that can build up very high voltages of the order of few millions volts. This is a machine that can build up very high voltages of the order of few million volts. And why this high voltage is required? So this high voltage is actually used to accelerate charged particles, like we can use it to accelerate electrons, protons, or any ions, which are required. So this can be accelerated to high energies which are actually required for some of the experiments. When we study about the structure of matter, we may need the high acceleration of these charged particles like electrons, protons, and ions. So in those cases, to accelerate these ions into very high energies, we can use this machine, because this machine can build up very high voltage. These voltages are required to accelerate ions or protons, electrons to high energies. We can write here, the resulting large electric fields are used to accelerate charged particles. The resulting large electric fields are used to accelerate charged particles. So these charged particles can be electrons or protons or ions. So what is the working principle? This machine works on the principle that when electric charge is given to interior of a conductor, that means when electric charge is introduced inside the conductor, then this charge goes onto the outer surface of the conductor. I'll write here, it works on the principle that when electric charge is given to the interior of a conductor, then it goes on to the outer surface of conductor, then it goes on to the outer surface of the conductor irrespective of the charge already stored on it. Irrespective of the charge already stored on it. So if you take a metal conductor and if you introduce charge inside the conductor, the charge distributes itself over the surface irrespective of what charge was existing on the conductor. So in this way you can build up very high voltage. Now let us see the construction of this generator. So here is a schematic diagram. So this Van de Graaff generator consists of a large spherical conducting shell. So this is a large conducting shell. Here I have marked it as dome. So this is the large spherical conducting shell. And there is a moving belt, and using this moving belt we can transfer positive charge from below the small sphere to this larger sphere. So by means of this suitable belt and this metal brushes, the charge is continuously transferred to the shell and a large potential difference is built up in this spherical shell. So a large spherical conducting shell is supported at some height above the ground. So this spherical shell is supported by an insulating column above the ground, and a long belt, which is generally made up of rubber or silk, is wound around two pulleys. So one pulley is here, another one is at the bottom. This pulley is at the ground level and another pulley is at the center of this large spherical shell. And this belt is continuously kept moving using a motor. The motor drives these two pulleys, and when the motor drives the pulley, the belt continuously moves. And the belt continuously carries the positive charge sprayed on it by this metal brush. The metal brush is used to spray the positive charge onto this pulley, and the belt carries those positive charge from ground to the top. This positive charge is transferred to the shell, and this positive charge then it is spread out uniformly on the outer surface. In this way, a high voltage difference of the order of million volts is developed. Let me tell you the working of this generator once again. A large spherical shell. So this is the large spherical shell. Dome. I'll write here. Large spherical conducting shell is supported. Large spherical shell is supported at a height several meters above the ground on an insulating column. A large spherical shell is supported at a height several meters above the ground on an insulating column. This is that insulating column. Now what? So next is a long belt, which is generally made up of rubber or silk, is wound around two pulleys. So there are two pulleys and a large belt is wound around two pulleys. The belt is continuously kept moving. The belt is moved using this motor. The motor drives the pulleys and hence the belt continuously moves. And this continuous movement of the belt carries positive charge which is sprayed on the belt using the metal brush. And it carries positive charge continuously to the spherical shell, larger spherical shell. So this positive charge which is transferred to this upper pulley is transferred to the shell using another metal brush. So there are two metal brushes here. The first one sprays the positive charge onto the belt. The belt carries the positive charge to the top pulley, and from this pulley the positive charges are transferred to the outer shell using the metal brush, another metal brush. Thus positive charge is transferred to the shell and this positive charge spreads over its surface uniformly on the outer surface. So in this way a very high voltage differences of the order of say around 6 or 8 million volts is built up, and the resulting high electric field can be used to accelerate the charged particles like protons, electrons or ions. So this is the working principle and the schematic construction of a Van de Graaff generator. So it is a device used to build up very high voltage of the order of billions of volts.